call it X?
The letter?
No, the
Twitter.
Twitter, but bought by Elon Musk.
It's not Twitter, it's X.
Yeah, I know, but does anybody actually call it X? Like,
No.
I'm sure some people do,
but why?
because that's its name. Do you call it the Sears Tower or the Willis Tower?
What are you talking about?
The big building in Chicago used to be called the Sears Tower. Now it's called the Willis Tower.
I don't know what you're talking about.
They changed the name of it. Why are you looking at me like I'm crazy?
I don't understand your reference.
Yeah.
They change the names of stadiums all the time. It's not Miller Park anymore, is it? It's American Family Park.
I don't know what either of those are.
Where the Brewers play. I don't blame you for not knowing. They're a crappy team. I wouldn't know where they play either.
I don't do baseball.
Well, it happens a lot in sports. Somebody buys the naming rights to a stadium, they change the name of it. So, same building, same place. They just changed the name of it. Good morning, ladies and gentlemen. How are we doing today?
I have magically conjured up a headache.
You have magically conjured up a headache. I'm glad I could be helpful today. Hang on a second, ladies and gentlemen. Get out your computers, get logged. Actually, get out your packets, ladies and gentlemen. You're going to need those more than you're going to need your computers.
Wait, what?
What are we gonna need?
You finished all those empirical formula and molecular formula problems?
Yeah, you never go.
I never gave you a packet that had formula determination problems on the front. Yep, we're going to put you in the room next door, okay, Zoe?
Okay.
And you can take the quiz there.
Yes.
The other one.
How did I do this?
I gave you a... Hang on.
This
No,
one.
you won't. It's here on me. Okay? All you're gonna have to do is do it.
I think it's this one. I think he's talking about this one.
He's a grocer at Walmart, and we're selling.
What are you? What is that?
It's the Christmas AI. I was trying to get it to go off topic. It told me to contact missing person.
No, it's a.
Contact Walmart. Walmart management. Missing person.
Why Walmart? Like, I get that they put it on their wall, but why are
No,
we at Walmart not like 911?
Walmart and works at Walmart.
Are you talking about this
I
package?
am not talking about this packet. I am talking about
Does it say calculated?
this packet.
I tossed it.
Oh.
What was it?
Why would you toss a 20-page packet after we've done 2 pages of it? Why?
That's a
Find it.
forest.
Look for it.
The
You'll
one
find
that
it.
says calculate formula method.
Well,
I'm a
didn't say that.
genius.
I tossed mine too.
Bro's getting her confidence back up after math.
That was the best.
Math? You were dying.
Stop. We don't talk about last hour. Last hour is in the past.
Last hour you weren't a genius?
Oh no, last hour it was absolutely idiotic.
No, you were a genius.
Oh.
Just not as.
You were an idiotic genius.
Huh?
Is this the one we're.
Yeah.
I got it.
When we look for things, it's amazing how often we find them.
I could make it.
If you bring something.
Mr. Bias, why are you wearing a jacket in my class? Again. Thank you, sir. Look at that. I got a 2-for-1. Andy's taking off of his and putting it in his backpack. Or you could go put it out on top of Ruby's coat out in the hallway. I'm flexible.
We did 7 pages actually.
We did 7 pages. What?
We didn't like it.
Why?
It's a little too bright.
I'm a little too bright for you? Well, I guess you're going to have to deal with it.
You're a little more pale.
2, 3,
I am a little
4,
more
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Any color. And all this.
All right, ladies and gentlemen. You need goggles for your lab tomorrow. Now, again, if you took them out of the box at the final exam day and put them into the correct box, they're sitting back there waiting for you. If for some reason you didn't bring goggles, or you don't have goggles, or you didn't get goggles, or whatever it is, you need to bring goggles, ladies and gentlemen. Otherwise, I will gladly rent you a pair for 50 cents a day. Okay? And by the way, the day is considered from the start of my class till the end of my class. Okay? So, your choice. Please bring goggles. If you have them here, we're great. We're good. We're ready to go. But you need them. On Friday, ladies and gentlemen, we're going to take a quiz. Only 2 questions on it.
How many points?
20.
What the fuck?
What?
Please, try to catch the fruit flies that are running around the room if you can, please. Okay? So, because I'm sick of those things. 2 questions, 20 points. 1 like the problems you are going to practice a lot today. 1 like the problem that we didn't count for anything other than extra credit on your quiz last week. Questions?
Can you give us an
Haley?
example of those 2 questions?
Haley?
Yes, Mr. Brand.
If I made it through chemistry in high school, you can, because you're much smarter than I was. So, okay, good. Questions? Okay. I have no question of the day for you today, although I did ask my first hour question of the day, and then I kind of asked my second hour question, and they sucked at the question after the way first hour went at it. So real quickly here, ladies and gentlemen, we've got 2 minutes. What is the worst superpower you could have?
The ability to see 1 second into the future.
Ooh, the ability to see 1
That's
second
so
into the
specific.
future. Okay, good.
Stop.
Hey, that's all right. We'll take it. What else?
What was the question?
What is the worst superpower you could have? What?
Look like that.
Ooh, wow. So you're a shape changer, but you can only change shape to look like Ben. You're right. New top 1 on my list, ladies and gentlemen. I thought the power to have incredible sense of smell was bad. That's worse. Okay, you got it. Good. Anyone else want to try?
The power to see exactly 1 minute into the past and no longer.
Wait, you wanted to see in the future a second ago.
Yeah, but now I have another one. I think it's worth.
Wait.
It's
Why
basically-
would you want to see into the past? It's already
It's
happened.
short-term
You asked for a
memory.
You asked for a dumb power.
That's true. Actually, the dumbest one I heard today was somebody said the ability to shoot pasta out of your finger.
So that's actually
That
amazing.
now could cure
Freeze
world
it.
hunger.
No, because it comes out really slowly. And then you have to wait a while before you can generate another pasta noodle. That was pretty bad.
It's a slow cure to world hunger. Nobody's
Any
ever
others?
done it
The ability to see what people are thinking.
To see what people are
I
thinking.
feel like that would be so bad.
So how do you see what people are thinking?
They're thinking about something, and you could see what they're thinking about. So it's and randomly, you don't even get to choose. You can't even look at them without seeing what they're thinking. That's weird.
Ruby, some people can't picture what they're thinking.
Correct.
Oh,
So how could you read someone's mind if they can't picture what they're
You
thinking?
just see the words.
Yeah.
Oh, so you got to actually read it?
Yeah.
Oh God, that'd be terrible.
That's just reading minds. Well, yeah, reading.
Yeah, but
minds,
she's
you know.
talking about actually reading it. It comes out in book form. Okay? Oh my gosh.
Or like text messages, but only one-sided.
Correct. If I had that power, it'd be easy to read Michaela. She doesn't think in long terms. It's okay.
Who?
Kidding.
It's you.
No, I was talking about you.
Ooh.
Well then,
Because
could've
you can
said
only remember a
Michaela.
minute
You said-
back into the past, so I don't have to worry about you
You
remembering
said
much.
Michaela. My name is Michaela.
Shut-
So
shut
therefore,
up,
you're
shut
talking about
up.
this one.
I don't know when you're doing
You bet. I will do one for you. You're going good, Zoe? Thank you very much. What's that? Okay. All right. There'll be different ones coming up. I got to pass. You can go ahead, Zoe. I'll get it going for you. Thank you. Where are you headed back to? Whose room? 316?
Yes.
Okay. Okay, thank you.
This is abuse, bro.
No, it wasn't. That was an accident. I do that to my brothers on accident all the time.
Okay, here's
Yeah,
the
I'm
thing.
sure it's on accident.
You two quit sitting next to each other, please. Please. Okay, ladies and gentlemen, so we're good with that. Let's get on to what we
I
need to
don't
today.
know if it,
Take out your packet. Let's look at question number 1 on it, ladies and gentlemen.
On what page? Question
On
number
one page, that is a great question. On what page are we looking at? We are looking at this one where it says formula determination problems.
Did we not do this?
There's a real good 50-50 possibility.
No, but there's, no, I'm talking about this one. Did we do this?
What's it say?
More mole conversions.
Well, you had lots of time to practice that if you needed them. Okay? All right. So, the composition of acetic acid is 40% carbon, 6.71% hydrogen, and 53.29% oxygen. Calculate the empirical formula for acetic acid. Okay? So, we're looking for the empirical formula for acetic acid. Can somebody tell me what the formula for acetic acid is?
It starts with H.
Good.
H something.
It's
H something. AQ. God, you guys are good. Never mind. We're great. Okay, I'm sorry. Alex, be a little louder, please. H. Ooh. Don't want that. Okay, Alex, since I have the attention span of a gnat, one more time again, please. H. Okay, good. Good. So, let's begin, ladies and gentlemen. What do we do when we're given these percentages, though? You cannot convert percents into moles. Not giving you anything. I will not give you anything that will convert percents into moles.
times it by 100 grams.
Okay. What we do is we assume a 100-gram sample, and that is perfect. That is perfect. We're going to assume a 100-gram sample. Why? Because we can assume any sample size we want. If you want to assume a 6-gram sample, you are welcome to take 6 grams times each of these percentages and figure it out. But the easiest thing to assume, ladies and gentlemen, is to assume a 100-gram sample. Now, why 100 grams, ladies and gentlemen? Because it takes your percentages and moves them into what unit? Grams. You don't have to do any math. You can just write them as 40. Whoops. Maybe write it the right way as 40.00 grams. Now, since this is carbon, ladies and gentlemen, I'm going to put 1 mole of carbon on top, 12.01 on the bottom, and someone is going to take and tell me how many moles that would be. While you, go ahead. 3.331 moles. Okay, now here's another important point, ladies and gentlemen. Ultimately, from all of this information, what are we getting? What kind of numbers? Whole numbers. So do not spend your time worrying about sig figs. I'm not grading you on sig figs in this problem. But here's what I will tell you. If we take this and round this to 3, you're going to have problems calculating your formulas correctly. Okay, that's too much rounding here. So my suggestion is carry 3 or 4 sig figs in this number and consistently do that throughout. Okay, I'm not going to grade you on it. If you do 3 on this number, 4 on the next number, 3 on the next number, I don't care. But if you round this to just the number 3, you're not going to see the answer that you should get. Okay? So sig figs aren't that important here. Number 2, we do not have to worry about diatomics. Why? Because this is part of a compound, the hydrogen. The oxygen is part of a compound. They don't need to be a diatomic because they are combined with other elements. Okay? Questions? Good. So, our next one, ladies and gentlemen, we take 6.71 grams of hydrogen times 1 mole of hydrogen over 1.01 grams. When we do the math here, what do we get? Okay, while you're doing that, 53.9 grams of oxygen times 1 mole of oxygen over 16 grams of oxygen. Grams and grams cancel out. I need someone to calculate these last two for me here, please, ladies and gentlemen.
So it was the last one was 6.64 moles.
Okay, and what is the bottom one?
Is that 40? What is the one at the bottom?
53.9, or sorry, 53.29 is what it should be. Divided by 16.
3.33.
All right, what do we do with these numbers, ladies and gentlemen? We divide them by what? Don't times them by anything yet. What do we divide them all by? What's the smallest number? 3.33. Now I realize what you're saying, Andy, with that 0.3s. We could get rid of it by multiplying it by 3, but first we got to get it into its lowest form. Okay? So what do we get?
1, 2, 1.
Now, here is where we look for a 1.5, a 0.33, something like that. Now, the reason that you will sometimes get those, ladies and gentlemen, is actually this. Okay? I don't want to do that. Hang on. This may drive my computer nuts, but okay, we'll try it. Yep. Today. Okay, good. They tricked me, ladies and gentlemen. Normally, the box in the corner says what? When something like this pops up the first time you see something.
Close.
No, normally it says, don't show me again, right? This one says, show me for new whiteboard. So I clicked it. No wonder why I keep getting this stupid thing every time. All right. So the formula for aluminum combined with sulfur, what would be the compound? Come on.
Aluminum sulfide.
Yeah, what would be the compound though? What's the charge on aluminum?
3.
What's the charge on sulfur? So what would be the formula? So when we put this into the term so that these come out to be a 1 by dividing them by 2, we get Al1, we get S 1.5, correct? Okay, and that is because this is a 2 to 3 ratio, not a 1 to something ratio. When we do that step where we are dividing by the smallest number of moles, we are always going to get one of them to 1. The problem is it may not be a 1 to something ratio. This is a 1 to 1.5 or a 2 to 3 ratio, right? So how do we get rid of this 0.5 at this point? We multiply everything times 2. Multiply everything times 2, which gets us back to a 2 to 3, a whole number ratio. So it is possible that when you divide by the smallest number of moles, you still may not end up all in whole numbers. we could end up with a 1.5, right? If that is the case, we need to take and we need to get this back to a whole number ratio, 2 to 3. Okay? So the 0.5 we are going to multiply by 2. All right? It is possible that you could end up with something that is like a 1.33. How would you get rid of that?
Times by 3.
Multiply it by 3 to get to 4. What if you end up with 1.25?
4.
Multiply it by 4 to get to 5. What? Why? Because it is possible to have a compound that would be Al4C3. It is possible that you could have a 4 to 3 ratio. Okay? It is possible that you could have a 4 to 5 ratio. Now, it is rare, but you could have chromium, which is a +5, combining with carbon, which is a -4, and that could be your formula. Formulas aren't always 1 to something. They aren't sometimes 2 to something. Sometimes they're a little bit unusual. Now, the only ones that I will give you are this one, and this one. Meaning on your periodic table, you may want to write down that if you get 0.5 in your ratio, you are going to multiply it by 2. If you get 0.33, you are going to multiply it by 3. And if you get 0.25, you are going to multiply it by 4. Okay? That's what it means. Okay? It is possible that those things could happen. Okay? It is rare, but it is possible. Questions? So I would just make a note somewhere on your periodic table for such a thing. Questions? Okay. So, what's our formula here? Based on the 1 to 2 to 1, what's our formula? C, 1. I never write ones.
H2O1.
Why are these different? Isaac.
Because if you multiply the empirical formula by 2, you would get the original formula.
Correct. Technically, there are 4 hydrogens here, right? The only thing we can ever calculate is an empirical formula this way. The formula written in lowest terms. 2 carbons, 4 hydrogens, and 2 oxygens can reduce down to this. Okay? Now, normally with an ionic compound, you'd never have to worry about it. Why? Because ionic compounds are already written in lowest terms. They're already written in lowest terms. However, in chemistry, for every rule, and there's no exception to that rule. Okay? There are exceptions. Here is a case where it is an exception. Now, we would never reduce this, right? Even though it's an ionic compound. But technically, it can be. But if we reduce this, what are we doing to this group? And we never change a polyatomic ion. So it happens to work out that because this is with hydrogen, it ends up that it is able to be reduced. But understand, that would be the formula. That would be the formula. Questions? Okay. All right. Now, let me clear this. I just want 1 or 2 more things to talk to you about real quick, then we'll let you get going. All right. All right, so here we go, ladies and gentlemen. Sodium, Na. What's its charge?
Positive 1.
+1. What is the name of this polyatomic? Find it on the back of your periodic table.
Oxalate.
Sodium oxalate. What's the charge on oxalate?
Negative 2.
-2. What would be the formula for this compound?
Na2C2O4.
What do you notice about that formula?
Divisible by 2.
It is divisible by 2. So why don't we reduce it?
That would change the polyatomic.
That would change the polyatomic. So understand, if we were finding the empirical formula for this compound, what would it come out?
NaCO2.
It would come out that. Okay? Now that isn't what the formula for this compound is. But there are a few exceptions where you may get a little weird thing like this happening. Okay? All right. Now here's the other thing. You do your formula and you get this. What would be that compound? What would be the formula for this compound? Please, feel free. Tell me.
MgCl2O6.
Oops, sorry. What compound is that?
Magnesium chloride.
That's how we write magnesium chlorate?
That should be correct.
Divided by 2.
Divide what by 2?
The number, guys.
You can't. There's a 1 by the mg.
Oh.
Divide the polyatomic.
Okay. This, is there any polyatomic Cl2O6?
No.
What's the polyatomic?
CO3.
Which means it was divided by 2.
No. What do we do to this polyatomic if we're going to if we had to balance off the charges? Right? Now, this is what we would get because this is the empirical formula. 1 magnesium, 2 chlorines, 6 oxygens, correct? But there is no polyatomic that is Cl2O6. But we do know that chlorate is a -1, magnesium is a +2, correct? So when you get this, you sometimes have to go and you have to think about what compound they are actually writing. Okay? C2O6, we don't have anything for that, but we do have ClO3. And there would be 2 of them in here. Now your empirical formula can't show you that. It isn't capable of doing it. This is where you need to use your knowledge of compounds. And say, all right, if magnesium were with chlorine and oxygen, and this is a 1-to-3 ratio, well, there must be 2 of them here, right? Okay? Just so you know. Now, if it's a covalent compound, if they're all nonmetals, you don't have to worry about it. You don't have to worry about it because we didn't give you enough information to figure out all the covalent compounds in the world, right? We did for ionic. Okay? So, you have got work time now, ladies and gentlemen. We're out of here at 38, right? Okay, you got a half an hour. You got a half an hour to get done what you need to get done. Now, if you get to the problems that ask you about a molecular formula, I'm going to talk about those at the end of the hour. But before you can do a molecular formula, you still have to do an empirical. So on a problem where it says to find the molecular formula, you still do everything we've been doing to find the empirical and then stop. And I'll show you how we go from an empirical to a molecular formula at the end of the hour. Fair enough? Good. Go to work. Go to work. Go. Go.
Sure.
Get to work.
Why? Because I don't feel gas.
Hey, who said you could move?
Okay.
Excellent. It'll be a lot quieter in here with her in the back and you in front. Go ahead. Go. Go wherever you want to go. Go wherever you want to go within the room. I don't care, but you mess up my lab, I kill you. I kill you. If you want to work with more than just that person sitting next to you because they sometimes know you, you are welcome to. All I'm doing is what you're doing in the process which means that by the way, answer keys are online, ladies and gentlemen. Okay? Please feel free to someone, have them up in your group. Have them there so after you do problem, you can compare it and you can tell me if my key is wrong. I don't have any lesson in lunch. This body looks like it can have that. It cannot. It cannot. My mind can exceed those expectations. I agree. It's my body that can't. It's all in the mind. No, I want it all in my belly.
should try.
This is which means that I don't have again, then you need to follow the district election. You know, whatever you don't do everybody else.
You should go down to the
Right. They don't come up here and hire us. I'm gonna go there to the no, she'll tell you. Yeah. So you consider a field trip when you go to school? Oh, you have to do that. That is how you run that. Because if you start rounding right here, when you divide by your smallest number, of course, then that rounding kind of adds up. When you divide that by the smallest number, if that were to come out to 1.5, yes, absolutely. In this part here, you're still getting these, you get about 3 or 4 significants that just sort of divide by it. Here's the thing. One point oh five, 2.16. But again, so if we rounded this, it works out. But when you get to something where it comes out to like sometimes your numbers when you see them, a little bit. Yes. That's about how much. Because that's about 6 and that's about 2. The only time we need to do the ratios is if that number is about 1.5, 1.32. Then you've got to do the ratio. Okay? That's the only side. It's coming out very close to a whole number. It comes out 2.1. You can round that up. It comes down 1.9. You can round that up. I just need you to take 2 to 4 and round it down to the first. It's 1.5. That's Which one of they almost $1 million. So, literally putting within regular scientists, probably at the class. Actually, then you should go. If you need to rain, you might as well go to the spring play, which is what? Yeah, you can learn about how they ended up having all their jaws fall off. Yeah, because they used to take the faces and they were making and eating radioactive substances out of the blood.
Dude, stop. Stop hitting me.
Normally, hold on. Years ago, what they like a 3. Now that's where you got multiplied by 3. Or you get a 1 and a 1.5. You got multiplied by 6. When you get to the point where you take 1 to 1, if you're shooting 1 is a whole lot, that's the one where when you get the players, they're in full strength, they may not be in the whole.
Not wanting to take all of these parameters and ask them. Oh. Okay.
Yes, sir. Now that you know My daughter is a senior in college and my son is a senior in high school. Because here's the other thing. My daughter doesn't live with us. She's going to school. And my son had never seen her in work all the time, so he whatever food they have in the house, we'll get. I'll let you know if you'd rather eat a burger than fries. I am. My daughter used to do that. She'd go in and she'd order on herself. Don't ask me. I don't know.
Maybe she had one bad experience.
Maybe.
I had some
Native American or from India? Okay. That's where I was involved. So like what did they put on? What did they put on? You don't know, you just say, yeah, it looks good. It was wonderful.
Oh my God! I just that makes so much more sense now. Now that I actually thought about it. Yeah. Oh my God, you're right. That's what it makes sense. The one thing we is that I trade. I do. Is that I price. Whereas the equal nitrite or per nitrite. Right? But we're definitely once the race to get to the ratio to 6, you realize that this would come out 4, which would have been NO2. That's why these empirical formulas are important, because they would actually figure out what God is real. One, two, three. That's again, when we get to it's a one. As long as we're close to Is that one number? Yeah, sure. I remember this one. What?
All right, ladies, gentlemen, children of all ages, come on back to your seats real quick here. I want to go through a couple things with you, clear up a little bit of confusion, hopefully. Again, if you have questions, please feel free to ask. Okay? Now, when we go from grams to moles, I ask you not to round too much here. Because if you round too much here, you may miss a 1.33, a 1.25, or something like that. Okay? So again, somebody asked me, how do you know how many digits you carry? Carry at least 3 or 4 digits that are not zeros. If it starts out 0 something, don't count that. So here, I put 3 digits after the 0. 528. Okay? That normally is good enough for you to figure out or you to see the ratio that you get. When you get to this, you don't always get whole numbers. But when you get one of them that is a 1, and again, you can round 0.9 to 1. You can round 1.9 to 2. You can round 2.1 down to 2. But if you get one of these that is 3.5, 3.49, 3.51, we cannot round a half down or up. It's too much rounding. And what it's telling us is that it's instead of a 1 to 2 ratio, maybe it's a 2 to 5 ratio or a 2 to 3 ratio. So here, a little bit of rounding is okay, but by a little bit, I mean maybe a tenth or so. If you are getting into the point where it is 0.25, 0.33, 0.5, you can't round those just to whole numbers. That is where you need to use that. All right, if I get a 0.5, I multiply everything by 2. If you get 0.33, you multiply everything by 3. So what you're doing here is you're ending up sometimes having to multiply these to get them to a whole number, because we got to a ratio where there was a 1. But not everything is 1 to something. Questions on that? Okay. So the last thing that I want to talk to you about is what we do if there is what is called a molecular formula. Okay? A molecular formula is a covalent compound that has had its formula reduced. So, with that in mind, ladies and gentlemen, if you have a molecular formula like C6H12O6, this is glucose, part of photosynthesis, and it can be reduced to what?
C2H3. I don't know.
You got off to the wrong step. You went C2. What can you divide all of these by?
6.
So C what?
C1H2O1.
Oh, okay. Now all we can ever calculate, the only thing we will ever get is an empirical formula from what I've been showing you. That's all we can get. The lowest ratio in whole numbers. Now, we can find what is called the empirical formula mass. Because this is an empirical formula, we can find its formula mass, just like any other formula, correct? Okay, so 1 carbon times 12.01 plus 2 hydrogens times 1.01 plus 1 oxygen times 16. So that ends up being 30.03 grams per mole. Any questions on how I got that? That's clear, correct? Yes? Well, to go from here to here, what did we do with our numbers? What did we do with those numbers at the bottom? By how much? We divided by 6. That's what we did when we reduced it, right? Okay. What if we find the molecular formula mass? Well, now we're going to take 6 times 12.01 and add it to 12 times 1.01 and add it to 6 times 16. This is 96. This is 12.12. This is 72. Correct? 72.06. Sorry. When we add these together, what do we get? $180.18. If you don't trust me, you can do the math. I don't mind. Right? What do you notice when you compare this mass? And by the way, this is grams per mole. What do you notice when you compare those masses? This mass is 6 times larger. That is how we find the molecular formula. We have to be given the molecular formula mass in a problem. There is no way you can know it. None. It has to be given to you. But when they give you this number, ladies and gentlemen, we take that molecular formula mass divided by our empirical formula mass, which we can calculate, and what we get is how many times we reduced our formula. What's the matter? Okay. These were the two formulas we were comparing. This is what you can calculate. This is what you can find. This is what we're teaching you to do. Okay? And when we're done, we can find the empirical formula mass by knowing there's 1 carbon, 2 hydrogens, 1 oxygen. That's this. Okay? Well, to go from this formula to this, we had to divide everything by 6. So the mass of this compared to this is 6 times bigger. So in a problem, I will give you this mass. I have to. And you will take it and divide it by whatever the mass is of the compound you found. And you will have to get a whole number. No halves. Maybe 5.99, 6.01. No halves. And the lowest number it will ever be is 1. Because it is possible that the molecular and empirical formula could be the same. Even for a covalent compound. It is possible they could be the same. But if you divide those masses, the number that you get is how many times you reduce the formula. So once you know what that number is, you take everything in your formula times that number. That will give you your molecular formula. That will give you your molecular formula. Questions? Okay, so that's what this is saying. It is the formula of a molecular compound. It is not necessarily in lowest terms. It can be, not necessarily in lowest terms. It is the empirical formula so many times larger. So many times larger. 2, 4, 5, 6, 10, whatever it is. That's how we go to an empirical formula. We divide it by a number, a whole number, everything. Which means the mass of this is going to be so many times bigger than the mass of this. Okay? How much time have I got? What are we at?
5 minutes, so like 4 minutes.
4 minutes? Oh, I got plenty of time. So you take the molecular formula mass, which you have to be given in a problem. If you'll notice those problems, I say the molecular mass, the molar mass of the compound is this, divided by the empirical formula mass. You find the empirical formula. When you find it, you can find its mass. This one cannot be smaller than this one. They might be the same, but this one has to be bigger. Has to be. And you divide them. That gives you some whole number. And again, you're not going to get a third. You're not going to get a sixth or a half. You're not going to get a quarter. You're going to get a whole number. Why? Because when we divided it by 2. We divided it by 3. We divided it by 5. Whatever it was. You are guaranteed to get a whole number. Okay? And you end up multiplying back by that. So, okay. Carbon and hydrogen. 4.98 grams of carbon. We convert it into moles. 10.47 grams of hydrogen. We convert it into moles. What do we do here?
Divide it by that small number.
Divided by the smallest number. Gives us 1, gives us 2.5. What's the problem with 2.5?
You just have to times that by 4.
No, why 4?
Because it's point. Oh no, you have to do 2.
We multiply it by 2. We multiply it by 2 because it's a half, which means our empirical formula is C2H5. The formula mass for that is 29.07. 2 times 12.01 is 24.02. 5 times 1.01 is 5.05. That gives us 29.07. Now, go ahead.
Do you divide 58.12 divided by 29.07?
Correct. They gave us the 58.12. We are going to divide by the 29.07. And we figure out that the molecular formula must be 2 times larger.
Could that number be a decimal?
No.
0.99?
Well, 0.99 that you could round to. It won't be 0.99. It could be 1.99. It could be 2.99. Something like that. Okay? Boom. We double everything in our formula. C2H5 becomes C4H10. Everything in our formula doubles. Okay? Everything in our formula doubles. Now, we could name this. What would this be? C4H10. Because there's only 2 elements there, we could name it. What? How many carbons? Tetracarbon, decahydride. More commonly known, ladies and gentlemen, is butane, which you will find in a lighter. Okay? So again, we can work on molecular formulas. Tomorrow, what are we doing? Lab. Bring your goggles. By the way, lab, strong acids, eat through clothing, eat through skin. Be cautious. By the way, if you have a portable gas mask at home, it would be a good idea to bring it tomorrow. Because if you have a sinus problem, we're going to clear them right up tomorrow for you, ladies and gentlemen. Right up for you tomorrow.
I waited.
So you're saying it'll help my asthma?
If it doesn't kill you, yes. Have a great day. Goodbye. Go away. Get out.
So I can get a lung cleansing, you're saying? That's what I need.
You're getting a full sinal cleansing.
That's what I need.
Put a note down. Forget about Haley.
My friend brought smelling salts.
Calculators. I still am missing one. Maybe 2, maybe 3. Who's got them? Thank you, Lydia. You got one, Abdi? Thank you very much, sir. James, go away. Go find Alexis. Go become Jax.
Yeah.